these would be very difficult. I'll send you through a few easier examples today.
Okay, that makes me feel less worried about it now.
Oh yeah, no, this is not easy at all. And the reason for it is because it's heavily linked with trig, as you can probably see. And it would be considered a hard trig stroke complex numbers question, together, both these two. All right, I'm struggling to find the questions here. Yep, it would help if I had it up on screen before I started, wouldn't it? Okay, so expand. All right, so question 3. All right, so hopefully the binomial expansion wasn't much of an issue. It was just a lot of writing.
Yep, that was fine.
Sine theta to the 4. All right, so when you do expand this, are you okay with this tomorrow as well? No. That doesn't matter. Tomorrow? Is she gone? I don't know where tomorrow is. I presume you're still there tomorrow. Okay, so you should get that 1, 4, 6, 4, 1, and then there was some I squareds and I cubes, and you had to make sure you had the right signs and stuff here, and hopefully you got that for the first part. Hence is part 2. Hence use Morse Theorem to prove that cos 4 theta is this. So if we equate what does it do? So 1, 2, 4, so the fourth. Okay, what were your thoughts here? I think I figured out what I've done now. What were your thoughts here, Sean? What did you do?
Well, that's the II, is it?
Yeah.
Using the Morse theorem, I just multiplied the theta by 4 in both of them.
Yeah. Okay. So the Morse theorem, the modulus argument would be 1 times cos theta plus I sine theta, really, wouldn't it? I suppose, if you want to write it like that, to the power of 4. So therefore, the 4th root of that and that doesn't really matter. So this is equivalent to that, isn't it? Pretty much.
Yep.
So if we let the real part, so cos 4 theta is the real part, and this is the imaginary part. If we just let the real equal the real parts of this, I think that is how we prove it. Cos 4 theta equals then the real parts from the above expansion, which is cos 4 and then minus 6 cos squared theta sine theta, and then plus sine to the 4 theta. Okay, and that's the real parts equated to the real parts, and I think the imaginary parts equate to the imaginary parts for part 3 then. Similar expression for sine 4 theta. So this was using the Morse theorem to get it in this form, so that has to be the same as that. So in part 3, the imaginary parts, when we let them equal each other, sine 4 theta from the Morse theorem answer is the same as the binomial expansion answer, which is going to be 4 cos cubed theta sine theta. This is this one here, and this one here, minus 4 cos theta sine cubed theta. Okay, I think that was part 2 and 3. That's how you get those. All right. So question part B. Tamara, are you there?
Yes, I am.
Okay. You went silent there. All right. For part B, they said let z equal this. Okay, so I will. Then what do they say? B is in degrees. Awesome. Let Z4 minus I. Where B is be a solution. Okay, so it is a solution which has the smallest positive argument. Find the modulus and argument of Z. Okay, so let's look at this. Z fourth minus I equals 0. Okay. All right, so let's use the Morse theorem on this. That means Z4 equals I. Can I turn that into modulus argument form?
Can't you just sub into Z and then say that equals that? Or is that not?
Sub into Z into this?
Yeah.
So explain what you would write then.
What I did was I wrote R to the 4 times cos of 4 beta plus I sine 4 beta equals I.
Did you find what beta is?
I got beta as well. I actually did it in radians. I didn't notice the part where it said degrees, but I got pi over 8.
Okay, yeah. All right. So what would be the angle? Well, let's use it in this. Let's do the Morse theorem from here. What would be the angle here, Tamara, that I would create? So I would be up here. What's its angle from the positive?
90 degrees.
Yeah, so we could say that's 90. What's its distance?
1.
1. Okay, so can we say then 1, or just nothing, cos pi over 2 plus I sine pi over 2, I suppose, would it be it in modulus form? And if we found well, or would be 1 then, if you want to put 1 in front like that. And then we need to find the fourth root of that to find Z. So it'll be the fourth root of that. And this.
And then you can just divide the angle, the argument by 4. Okay.
Yeah, and the same thing. So we're looking for the fourth root of this, fourth root of that. And then your little sidebar, if you want to do, it's going to be pi over 2 plus 2k pi or 2n pi, whatever you want to do, multiplied by a quarter, I suppose, if you want to do it like that. You can tidy that up a little bit. It's going to be pi over 8 plus, it's going to be k pi over 4, isn't it? Oh no, over 2. Sorry, 4 and 2, yeah. Okay, so that will be the Morse theorem bit that you can shove in for each root. So it's going to be just, don't need to do the fourth root of 1. We know it's the fourth root of 1. So then it's cos pi over 8 plus n pi over, or k pi over 2. And I sine the same. Okay, a bit crushed in there. Okay, so therefore at its, then we use at its smallest positive argument. So the smallest positive argument must be then where k is 0. That'll be the first one, be the smallest angle. After that, it's going to go further and further and further away from the positive real axis. So when k is 0, yes, it's just pi over 8 then, isn't it? Theta must be pi over 8. So because pi over 8 plus I sine pi over 8, if you want to do it out fully, and pi over 8, as Sean says. Now we need that in degree. Or is 1. We knew that from before. So that's the modulus. Okay, yay. The argument, I can't have it in pi over 8. What's pi over 8 as degrees?
22.5.
Yes, it is, because pi over 4 is 45 degrees, and pi over 8 is going to be half that then. And pi over 2 is 90 degrees and all that. Yeah, so that's 22.5 degrees. All right, so that was not initially a nice start to this question, I don't think. But, and that's when k is equal to 0. So there would be more. Part C then says use A part 2 and your answer from B. So A part 2 was this thing, and your answer from B, so here, to do what? To show that 8 cos 4b. So we want to show that 8 cos 4 beta minus 8 cos 2 beta plus 1 is equal to 0. So my first bit from, let's take this down from part A, 2. All right. I really should, because we're using beta now, I'm going to change all these to betas.
Yeah.
Perhaps you did that already. I should have done that as I was writing it. I just realized that now. Okay, so I changed them all to betas. Beta is 22.5. Can I say that then this, if beta is 22.5, that this bit, can I do that this bit is cos of 90?
Yes.
All right. Now, it's not as easy with our fourth power betas and all that. So let's tidy that up a little bit using some trig identities. I don't want, I see cos and 1 here. I don't want any causes in this. And I got a sine here I don't like, and a sine here I don't like. Now, you see, the reason I did cos 90, I changed that to cos 90 because I know that's 0, isn't it? The cos 90 is 0. So that would give me this bit. Eventually. Well, let's do cos 4 beta. Don't do anything to that for a second. Did you get this, Sean?
No, I didn't. I was trying to do this, but then I couldn't figure out how to make it look like that.
Yeah, cos squared beta. Sorry, that should be sine squared. Sine squared beta, then I'm going to change that to the cos one that I know, to minus cos squared beta. I think I can do that. That's one of the identities. And sine to the 4th beta, well, that's just sine squared beta twice, isn't it? Squared.
Yeah.
Which is this same identity squared. 1 minus cos squared beta squared. All right. So this bit, if I want to square that out, it's going to be 1 minus 2 cos squared beta plus cos 4 beta. That's that bit done. This, all right, let's do it from here as well. 4 beta minus 6 cos squared beta plus 6 cos 4 beta. I think I'm okay. Plus, can I do that? Am I happy with that? All right. Does this work? So what did I want? 8 cos 4 betas. There's 4 of them. One more. There is 8. There is 6 of them. Sorry, there's 1 and 1. So there's 8 there. Cos 4th betas. Okay, they're gone. I also want, okay, it's all there. Is it minus 2 and another minus 6? That's 8 cos squared beta. That's gone. That's gone. And I'm left with plus 1. Okay, plus 1. That equals 0. I think it's okay. I think it worked out if you expanded it. Are we okay with that?
Yeah, okay. I just didn't manage to get that.
Okay, so it was more of a algebraic error, really. If you had this and then get.
Well, it's because I was trying to do something. I didn't use the same ones as you did, so then I ended up not knowing what to do at some point.
Okay. Yeah. Okay. Yeah. I must admit this question did take me a while, so I'm not surprised that you guys were struggling on it too. Yeah. Okay. So part D then. Hence, maybe I'll switch pages. Okay, part D. Hence, no, I won't. I'll try and squeeze it down here. Express cos 22.5 degrees in the form. So you should be able to have been able to do this without the previous part, because they gave you the answer in the previous part. I think. Right. So this is like a quadratic, isn't it?
Is, yeah.
Okay. So maybe could I solve it for cos squared beta? I could get cos squared beta out of the quadratic. The reason I use the quadratic is, and I'm going to use the quadratic formula, is because I look at the question, which I don't know if you're looking at it in front of you. It has this as the answer: a plus b root c over d, and this part of it suggests to me that solving this quadratic is going to help me. And of course, if I know cos squared beta, I then realized that if I were to find just cos beta, I would just square root whatever my answer would be. So I'm seeing that. So maybe you see that too. So minus b from this would be 8 plus or minus the square root of, well, it's going to be 8 squared, 64 minus 4 a's, so 4 times, so that's 32 times 1, okay, all over 2 times 8, so 16, okay? So that simplify that down a bit. 8 plus or minus, that's going to be root 32, isn't it? So root 32 over 16. I think we can simplify this even further. It's going to be divided by 4. So it's going to be, because that's going to be root 32 is going to be root 16 times root 2, isn't it? So that's going to be 4 root 2. So it's going to be 2 plus or minus root 2 all over 4. Sweet. Okay.
And then you just square root that, and then that's the answer. Okay.
But plus. There's a plus here, and it says plus or minus.
Oh.
So we need to be absolutely sure why we're getting rid of plus or minus. So we know what cos squared beta is, and 2 plus or minus root 2 over 4. I know if I get the square root of that, yeah, that will get me in this form. But which do I take? Do I take plus or do I take minus?
You would take, with where 22.5 is, you would take, I don't know.
Well, think about beta. What 2 answers is this going to give?
It's going to give, is it going to give the one of them and then the, no, because that's not an imaginary number.
Okay, so first of all, it also should be plus minus here.
Yeah.
Sorry, there's 2 plus minuses. So we have to be sure of the signs that we're going to take. All right. So what's the, all right, let's go to one that we know. What's cos 45 as
root 2 over 2.
Root 2 over 2. All right.
So it has to be less than that, but it has to be greater than 0 still. Because
is cos 25 then 22.5?
Oh wait, no, that's bigger. That's bigger. Sorry.
Yes, it's bigger, isn't it, yeah?
Yeah.
Yeah. So it's going to be bigger than root 2 over 2. So is it going to be plus or minus?
Plus.
It's going to be plus. So it's going to be bigger. So, and what about the one outside the bracket? Outside the square root?
That's also going to be a plus because it's not negative.
Yeah, because it's not down here. It's up here.
Yeah.
So it's going to be plus outside, it's going to be plus inside. So I can leave it like that. But I think in the question, the square root is only above. Sorry, I've written this wrong. Square is above. So I got to get the square root of 4. So it's actually the square root of 2. Plus, if you read the question, there's actually the square root's only above the line, all over 2, like that. They're both positive, and we just have to logic that bit out because we know 45 is root 2 over 2, and 22.5 for cos is actually going to be greater than that, the ratio, because it's closer to the x-axis or the real axis or x-axis. It's actually down here, which means this length is longer, this length is shorter. Sine is the opposite. Okay, whew, we got there. All right, so that was question 3, which took us about 25 minutes to do. Many marks just for that. 19 marks for that. So that was, so that's about right for the amount of time. Maybe it took us, maybe we didn't start this class on time. So yeah, we did it in about the right amount of time, but it was not easy. I don't think question 4 got any easier. In fact, it might even be more difficult. It's very trigonometry heavy, this one. Okay, so part A. Sine x plus 90. Solve this equation. Okay, equals 2 cos x minus 60. So this is really testing our trigonometry skills. In its present form, I can't solve it.
Yep.
So I'm going to use some compound angle formulas to get rid of these compound angles. So I'm going to do the sine compound angle formula here and get sine x. So this is from cos 90 plus cos x sine 90. Did either of you get an answer for this, by the way, while I'm doing it?
Yeah, I got 180 and Tamara got the same, I think.
Okay, you're on the same page. Well, I'll just fly through it anyway, just in case everyone watched this video again. 2 cos x cos 60 plus 2 sine x sine 60. And now we have our known angles. That's 0, so that's gone. That's 1, so this is just cos, sine 90 is 1. So that's just cos x on this side. And then we get, that's a half, so that's going to be just cos x here, because cos 60 is a half. It's going to be root 3 over 2, and the 2's cancel, so we're left with root 3 sine x here. Causes cancel over this side, so we're left with 0 is equal to root 3 sine x. Well, sine x is just equal to 0 then, which means x must be at 180 degrees. Something like that, I hope.
Yep.
Okay. Part B then, did we get a part B? Did we show that?
Yep, with 45 and 30 degrees.
Yes. So sine 15. Tamara, do you want me to go through part B?
You got it faster than I did, actually.
Yeah.
Oh, sweet. Okay, so that is how you do it. I'm not going to do it out. Cos 45 minus 30. Well done. And you should get. It's to show that, so you have the answer. Okay, using those two. All right, part C then. Did you get an answer for this? The modulus and argument. What was your answers?
Did not. I got very lost.
Okay.
I was not sure. I thought that finding the modulus, I would just like square the real, square the sine. Square the imaginary, add them, and square root. But
Yeah, it is.
It is that.
Yeah.
Oh, I can turn that into sine squared, can't I? Yes, I can. No, I can. Yes, that turns into 4 sine squared. Then that's okay. So that means like the modulus should be 2 sine squared 2 theta. How does that help?
Very close. Yeah. Very close.
Sorry, just 2 sine 2 theta.
Yes, 2 sine 2 theta. Yeah. Sweet, you got it. Tamara, do you want me to run through it?
Well, that's the modulus. I didn't get the argument.
Yeah, the argument's rock hard.
Okay.
I think it's the hardest complex trigonometry question. Yeah. Anyway, I'll do the modulus and the argument, sure. The modulus of z is going to be just square the real part, square the imaginary part, add them together, get the square root. So 1 minus cos 4 theta, this is given in the question, squared, plus sine 4 theta squared, and square root all that. So I'll just put it to the half because it's easier to draw. When I square that first bracket out, I get 1 minus 2 cos 4 theta plus cos 4 theta squared plus sine 4 theta squared, all square rooted. Okay, so these two together conveniently form 1, don't they? Squared and squared. So that's 2 now. Instead of 1 here, that's going to be 2, adding this 1. So that's 2 minus 2 cos 4 theta. And square root that. I want something I want to can get the square root of. So I want it squared in here, don't I? And I want to get one term if possible. So I want to try and combine. And there is a double angle formula that can help me. It's sine 2 theta, the cos, and the 1 minus sine. All right, so let's do that. Let's convert this into 1 minus, so using the double angle formula. What is it when I convert it? Either of you?
I turned it into 4 cos squared 2 theta minus 2. But are you just doing that bit? 1 minus cos squared 2 theta. You haven't multiplied by 2 yet. 2, yeah.
No, I haven't. No.
Oh, wait, are you doing sine? You're doing sine.
I'm doing cos 4 theta.
Yeah. Yeah, but
I'm converting it to sine.
Yeah, okay, sine. I turned it into cos.
Okay, well then, so this would be 1 minus 2
Sine
2 theta squared. And that's 2 minus still. 2 minus 2. So I've just replaced this using the double angle formula. And that's still all square roots. Now I'm just trying to do this bit by bit to tie you up. So 2 minus, so it's going to be 2 minus 2. I'm just multiplying in by this minus 2 now, plus 4 sine 2 theta squared all to the half. 2 minus 2 is gone. So you're just left with 4 sine 2 theta squared to the half. So now I can get the square root of both these. 2, so 2 is the square of that, and the square root of that is just sine 2 theta. Yeah. So you went a slightly different route, but you got there, Sean.
Yeah.
Yeah, so the principle is pretty easy. Just square them both and get the square root. But to get the trigonomic ratios you want was difficult. To use the right identities to get down there. This jump using the was probably the hardest to get from. So I think in the formal booklet, of course, is 2 theta down to 1 theta. So 4 theta down to 2 theta. All right, so the argument now. All right, so this is where you could have a little look at a random. If you wanted, you could draw your attempt at Z. So let's say, just for example, that this mightn't be right, but let's just say that this is 1 minus 4 cos 4 theta, and we've got it's up. This is not it, obviously, but up sine 4 theta. I know it's down, but that's okay. That's just for this example. The angle here is based off the ratio of these two, isn't it?
Yeah.
So at the moment, I don't know what that angle is, but I know it's based off these ratios, and I can get the ratio of those two, but I can get the tan of the argument by putting one over the other, couldn't I?
Yeah.
Okay, so let's do that. That sketch was inaccurate before you just to show. So if I get the tan of the argument, perhaps that will help find the actual argument. Because the tan of the argument will be the imaginary divided by the real. 1 or minus sine 4 theta divided by 1 minus cos 4 theta. So I'm going to manipulate this down. So hopefully on this right-hand side, I can write tan something.
Yeah, okay.
Using trigonometry. So maybe something like tan pi over 4. And then, the argument's pi over 4. So that's my plan, using trigonometric identities and such. So I think I can break that down. That's like sine 2 theta, isn't it? So if I do that formula, I get 2, I think I can write 2 sine 2 theta cos 2 theta from that one.
Minus, right?
Yeah. This one, I do the same one I did up here. The same double angle I did up here. So I get 1 minus, okay, in brackets, I'm going to do this one, 1 minus 2 sine 2 theta squared. And I did that because I know that that's going to get rid of these ones. The same way it kind of got rid of the 2's here.
And then you'll be able to cancel one of the signs.
Squared thetas, yes. I'll also be able to cancel the 2. So that breaks down, the 1's will cancel here, and that's going to be positive 2, isn't it? So it's positive 2. That cancels with that, and we're left with minus 2, which is positive 2. That positive 2 cancels with that positive 2. Well, 2 cancel 2. We still have a negative up here. So the whole thing is going to be negative, I know that. On the bottom, there's sine squared, or sine 2 theta squared, and there's a sine 2 theta here. So that one's going to go with one of those. So I'm left with cos 2 theta above and sine 2 theta below.
Okay. It's almost like tan.
Almost like tan. In fact, it is 1 over tan, isn't it?
Yeah.
Or what's that called again? 1 over tan is cot, yeah. 2 theta. Oh, you can write that one. Okay. Now this is where you want it to be tan, don't you? So
yeah,
I need to look at 2 theta now. I need to look at the relationship. Can I change cos 2 theta into its sine equivalent?
Yeah, you can turn it into 1 minus 2 sine squared theta.
Okay. If the cos was 10 degrees, what's the sine?
Oh, like that. Cos is 10, then the sine is that maybe 80? Wait.
Yeah. So think cos 30 is the same as sine 60, isn't it?
Yeah.
All right. So how do I write that with 2 theta now?
90 minus 2 theta?
Yep. And the same for sine 2 theta. If I want to change it to cos, it'll be 90 minus 2 theta. Okay. So let's bring that into this. So now I have sine over cos. Minus, though. Sine, what is it? Sine pi over 2 minus 2 theta over cos pi over 2 minus 2 theta. Now, I don't want, that's negative tan. That is pretty much negative tan.
Yeah.
Pi over 2 minus 2 theta. Now I don't want negative tan because I still have tan over here.
Yeah.
What's the relationship between negative tan and positive tan? So let's just do tan x. Negative tan x is the same as tan what?
180 minus x? Is that it?
180 minus x?
Yeah. Is it?
You have a calculator there. Maybe have a little look. Oh, nearly out of time. Well,
yeah, it is that. Oh, that works as well. Oh, right, there's a different one. Yeah, okay, that's the same. Yeah.
Yeah, it's probably, yeah. So this is another known identity. Perhaps you don't know it yet or haven't come across it, but it hopefully makes sense.
Yeah, because tan is negative there.
Yeah, it's negative there and there. Okay, which means I can just say, can I just make that negative? So tan, swap 2 theta then minus pi over 2. By this thing. Which means that is the argument.
Okay.
Now, I wonder how many people got that when that was an exam question. Not many, I'd say. The fourth roots from there, I am suggesting you can finish this off yourself. The fourth roots would be the modulus, argument, the Morse Theorem, fourth roots, sub in k.
Can that still be in terms of theta? Or does it want that?
It would be in terms of theta, wouldn't it?
Okay, yeah.
So you'll have, it'll be written awkwardly, and there's no need to simplify it anymore, because it'd be like, I think it's like theta over 2 minus pi over 8 plus k pi over 2 is what you're you can try this, and we can run through it tomorrow if needs be. Pi over 8 plus k pi over 2 is the, and you can see where that comes from when you're finding the fourth roots.
Yeah.
Divide that by 4, divide that by 4, and then you have your rotations divided by 4.
Yeah.
And that's your cis or your cos I sine. So that's the 2. Yeah. Okay. All right. So you can try and finish that off. I'm going to post on ManageBack for you guys more complex numbers questions. Some, I think there's only one difficult one. The rest of them are fairly on the medium side of difficulty. So you can get to as many of those as you want before tomorrow if you have time. If you don't have time, it's okay. I'll just run through a couple of them. Okay?
Okay.
All right, and we'll see you tomorrow.
All right. Thank you. See you, sir.
Bye, sir. Thank you.
Bye.